Hi, welcome to the third installment of the BitArray series. Uh, I didn't intend to make a series about BitArray, but what happened is I wrote it in a playground and made a video of it, and then I made another video about open sourcing Swift project. I happened to use the BitArray as an example. And that was intended to be the end of that. And there's two videos are almost orthogonal, except at the end of the second video, I realized that the project is in a pretty bad shape when I left it. For example, we don't have README, we don't have any documentation, or the source code doesn't have docstrings, etc., etc. So I decided to work on it some more before I actually make the open source video public, so that when people come to this repository, they'll see everything ready. And therefore, I decided to make this video, and also I now consider these three videos to be in a series. Anyways, so this is what we got at the end of the second video. It's the BitArray project is now a pretty well supported project with linters and all kinds of supports for package managers, except that it doesn't have things such as the license is just a placeholder, and the contributing file is a placeholder, and I believe the changelog is empty as well. Okay, so we'll fill all that in. So I'm going to start by making a to-do file, and our goal is to delete this file towards the end. Okay, so what we're missing, we need README with like installation, and maybe something, maybe more in there. And we need the contributing file. We need license. We need docstring for source code, right? We need to make a tag. I'm not sure if we can get to this point, but I also would like to test the integration. Well, let's not do that in this video. But also, this is not all. I also want to add new functionalities. So let's look at the source file real quick. I have some cleanup suggestions as I was thinking about the documentation. And I want to add a bunch of more interfaces. For example, our code, our type, since we claim it's an array, it should be expressible by ArrayLiteral. It should have a custom string convertible conformation, because it helps us with debugging a lot. And finally, I want to make it equatable, because it's just very, very useful. I'm pretty sure that this is still behind the full interface of an array, but I think with these additions, I'll feel much better about it. Okay, so as you can see, it's a big list. It's a mix of different kinds of stuff, right? And it's going to be hopefully not terribly long for this video to complete. And yeah, and I'm ready to get started. Okay. So let's just go down the list one by one, right? I'm going to start by going back to the playground. I have it open. I just deleted the content to begin with. But this is the code we had from before. And there's a couple of improvements that I guess I can add that as well in our to-do list, just so we have more sense of accomplishment when we're done. Improve code API or something like that, but it's not really just about interface. For example, the first thing I want to improve is the fact that we called the storage a store, which is fine. It tells us its role, but I think it's kind of too generic. So maybe to combine the fact that it's to improve its self-documentedness, let's call it byte store, just so the reader can see, okay, this is actually it's a store, and also it's stored in byte. Since I think I just do the replacement here, and it kind of also lines up with our variables like byte count, right? Byte count and byte in the byte store. It's pretty clear. All right. The next bit I want to improve is this fill pattern. I think, again, along the same lines of thinking, I'm going to call it byte fill pattern. Hopefully that'll give the user more information. Okay. And I believe that's all the improvement I want to make here. So let's check that off. All right. So the next bit we're going to do is expressible by ArrayLiteral. So let's make an extension. And this should be fairly easy to implement. Let's see what Playground tells us. Okay, so it wants the type of the element, and we can give it this as a hint so that it can just suggest the next step. Towards the end, though, we don't really need that. Yeah, because of this, because we, if we now delete this, you'll see that this should work. Okay, so this makes me want to make another improvement to the API itself, because yeah, this is a var arg of bool, which is fine, but you know, fundamentally it's an array of bool, right? So that makes me realize that we should probably support initializing our type, our bit array with array of bool, right? That seems reasonable. So let's do that. Let's call it bools, and it's a bunch of bool. And we simply can do self.count equals bools.count and and then we just go down the list, right, and mutate the content. Yeah, I should do this. I should do like self.init and give it the count. So this will give us the storage we need, and then we'll mutate the content. So index and value in, let's do a zip of from 0 and our values here, and use the subscript. So that's easy enough. And now we can go back here and implement ExpressibleByArrayLiteral, and we simply invoke the other method, the other initializer. Okay, so that is pretty sweet. Now we can use syntax like this: array, bit array, and then we'll just say true, false, true, false. Right? Okay, yeah, so that worked. But this brings me to the next requirement, because for example, in Playground or with a print statement, we currently can verify that the content of this is actually initialized as we expected, right? So it's probably very beneficial to give user that information. So that is why we want to implement CustomStringConvertible. CustomStringConvertible. Okay, and this is fairly easy to implement as well. Should be. This protocol requires us to have a description variable of type string, and we can use the fact that we are a collection, so we can convert ourselves into an array and then just forward its description. Now, this should be pretty sweet, right? True, false in the literal, true, false in the description. That's perfect. While we're at it, I saw this flash by and reminded myself that we probably want this as well, because it's kind of just, it's free. So we just copy everything here with a debug description. And we just return self.description, and that's that. Okay, done. That's pretty fast. This next one is more interesting. It'll probably take more time. But before we get to that, I think we can make this part, this initializer we just added, even better, because why restrict ourselves into an array, right? Array is just a collection. So let's take a collection instead. So I'm going to turn this into a T, and then Swift will scream that T doesn't work because we have a bunch of assumptions in the implementation. So we'll restrict T to other types. For example, T should be a collection, and then now it's screaming that its value is different, it doesn't have a count, stuff like that. So we should say T dot element is bool. Now what? Okay, so we're good with this part, but now we have to deal with the fact that collections index distance is not the same as bool. So T dot index distance must be an integer. I wonder what that does. Well, let's see. Just waiting for Playground to catch up here. Okay, maybe you can help it a little bit by doing this. I think this will work. So now, yeah. So now we can suddenly initialize a big bit array with, like, say, a set. Right, perfect. And we can even have contents inside the set. What's interesting about set is that the resulting array may have different orders and values, I guess, because set will dedupe the value. Anyways, set is just an example, maybe a bad example. Okay, So going back to our to-do list, we did the 3 things. Now we're going to make this array equatable. So equatable requires us to implement the equal operator, and inside we get 2 arrays. The first thing we can consider in the equatable is the number of bits for on both sides, right? So the left-hand side and right-hand side. So if they're different, then, well, these 2 arrays are different. So that's a you can call it almost like an optimization. Instead of looking at the content, we can just say, no, these aren't the same. So return false, right? And then again, to make the compiler happy, while we are typing, I'm gonna return a phony value here. Okay, get that out of the way. The next part we should consider is the fact that we need to think about the last byte in the storage. This probably will result in kind of like an ugly-ish implementation, because we need to think about all kinds of edge cases, right? If if we're empty, then there's one thing. If it's not, then we have to take out the last byte, and then maybe as we go down the list, okay. Let's handle the last byte first, because after doing that, all we need to do is walk down the first, the rest of the bytes, right? So that seems like a reasonable plan. Okay. All right. Let's handle another edge case. So if the left-hand side is empty, then we just say true, because we consider 2 empty arrays to be the same. Okay. All right. Again, this is wrong. It should be if they're different, then it's not the same. Okay. All right. I'm thinking, how is empty implemented, because it's actually, we got it for free by conforming to access collection. Hopefully this guy mentions count, and then we're just saying the count is not 0 instead of actually walking down the buffer. So okay, we'll get back to that. Otherwise, we could say like self.bytes.byte store is empty. Yeah, let's operate on that, because we're going to operate on the level of bytes anyways. Okay, now we can safely be sure that our bytes have a last value because it's not empty. The next step is to chop off the unnecessary bits inside the byte. And since we filled in the value in the byte this way with a mask, well, I'll just simply copy this here. And we'll call this like a truncating mask. How about that? And here, basically what I want to do is get rid of the unnecessary masks. Let's look at some examples, right? So if I make like a length 3 bit array and I fill it in with this pattern, 0, 0, 0, 0, 0, 1, 1, 1, right? So all bytes are ones. Then you'll see that, okay, the description tells us we have 3 true values, or maybe to make it slightly more valid, more diverse, let's add a false value in there. So what I want is that no matter what these values actually are, for example, I can say this is 4, right? Semantically, oh, sorry, not 4. I can say this bit is 1, but semantically, we don't really care. And that should be the same for Equatable, meaning I want to make all these values the same when we're comparing that byte here. And the way to do that would be, so okay, we know we have 3 for this byte, we care about 3 of the bits, right? So we'll be looking at this one. So that means I want to make all these values the same no matter what. Let's just make them 0. And I can achieve that by using a mask and like this. And then I'll perform a bitwise AND with the existing value. So if you look at this mask and this mask and do a bitwise AND, you'll see that 1 and 1 again is 1, and 1 and 0 is 0, so this 3 remains the same. And then since the rest is all 0, then that means all these bits become 0, right? So this is a mask, and I use a bitwise AND with it. Okay, so that makes it pretty clear what I need to do, which is create these masks like so. And the good thing about this is once you worked out the example, you don't have to think too hard about the rest, because we chose a pretty consistent pattern here when we implemented the bit array in the first place. So all these needs to be 1, and last but not least. All right. And now I can get this byte and can get that byte. Again, we can do this because we know it's not empty, so this is safe. Or maybe a more swifty way is like guard let this and that. Guard let this. Now I can get rid of this. That. Else, well, the only way both of these can fail at this point is the fact that they are empty, so we can return true. Now I think I can even get rid of this. Perfect. Okay, so having the last bytes of both we can get the remainder. I don't know what to name this stuff anymore. So last byte length, how about that, equals one of the counts modulo 8. So again, in our example, this would be 3 bytes. Then we're looking at 3, so we know the mask would be 3. So let's get mask is self.truncating mask for last byte length. So now we got this. Wait, what's going on? Oh, not self dot. Well, I guess we can make it a static function. Then we can use self dot. Okay, I'll do that. Now we're ready to compare, right? So if at left-hand side last byte bitwise with mask is different than right-hand side last byte bitwise with mask, then we know that these two arrays are not equivalent. All right, something is wrong. Bool and oh, these again should be byte store, right? Okay. Now that we've handled the last byte, the rest should be easy, right? We'll start with a index pointer cursor from the beginning of both of the storage, and we can say as long as this value is smaller than, for example, left-hand side of count minus 2, because we've handled the last one. Then, well, at the end, this is basically a C for loop. And then if any of the values in the byte store is different, we can say that these two are not the same. And at the end, we've cleared all the conditions where the two arrays are not equivalent. Then we can safely say they are equivalent. All right. Let's test it out. So we have an A example. We'll have a B example. And let's look at whether they are the same. They should be the same at this point, but if I increase, let's change this here as well. So even though these two actually the fill pattern are different, we know that inside the 1 byte is different. I expect these two should be the same, but now they're not, which is interesting. Oh, well, that's not great. Okay, so what happened here? Did we return? Oh, this should be byte store.count. Okay, let's rejigger this again. Okay, now this is reporting true, meaning A and B, even though they are filled, initialized with different patterns, we're only considering the last 3 bits. That means if I make, well, first of all, these 2 counts are different, right? So the count difference should short circuit everything and make them different. But if I take the first 4 bits into consideration, then they're different now. Great. Now let's make them the same again. And just change some random garbage bits, and they should stay equivalent. Okay, now that makes me feel pretty good. All right, so now we have Equatable, I think. Okay. Okay, so that's all the code changes we want to do. I guess while we're at it, we might as well start writing documentations. Yeah, and to increase our chance of success, I'm gonna exit our exit the playground and come back to Vim. Uh-oh. Sources, BitArray, please. Oh. Okay. Okay, now we have all the changes here. We can start writing documentations. Count is number of bits. And this is initializer, so it creates a array with filled with 8 with repeating. Let's add parameters. Pattern. This is an 8-bit pattern used to initialize content of the array. Used repeatedly. How about that? Repeatedly. Okay, next one. Create an array. Create an array from with identical content from another. Array to copy content from. Okay, next one is create an array with content specified 8 bits at a time. How about that? we can copy this one. Number of bits in an array. And the next one is content. Actually, I just realized the content is not the best name. Byte content. I can say 8-bit content. Content with bytes. Content from bytes. Yeah, sure. Content by bytes. Maybe. Naming things on camera. Bytes, okay. 8-bit values for content of this array. It's kind of vague, but I'm hoping that this is actually exposing the underlying implementation to the surface, and I'm hoping by convention people will understand what that means. Well, that's not the best way to think about documentation, really. Content, how about content of the array 8 bits at a time? All right. This one, we create an array from specified values, Boolean values, okay. This would be self-documentary. The type is pretty clear. Commented bools, collection, okay. Now we have subscript. Hopefully it's the last. What's the function of subscript? Access array. Access array content by index. So access obviously is both read and write, right? Both getting and setting value access is O1. Yeah. The word array in the type name should convey a lot of information, so I won't elaborate too much except just say this has a performance characteristics. And then for the rest, since you're just implementing standard library types, protocols, we don't have to specify documentation. Okay, so where we are now, we have docstring for source code done. Well, the rest will be smooth sailing. I'm gonna start cheating now by copying stuff from my other project. There's a license here. I don't even know if I need to use Vim for this, but why not? Copy this. The project name needs to change, the rest can stay. And that's how I deal with law, friends. No, please don't take advice from me. We've done this. We can write to do and contributing. Yeah, let's do readme. Okay, so we have a very brief, efficient description here. We may want to add like a usage section, right? And we can put in some example here. For example, array specified by number of counts create an array of length 3, and then yeah, a dot 0 false, a dot 1 equals true, a dot 1 now it's true. Maybe we should add a description. Use this type as if it's an array. The special I'm not sure if we want to describe all the changes, because we can ask user to look at the doc string and type signature instead. Maybe you can say specify number of bits to store in an array when creating array. Okay, so that's the example. Standard So let's demo the ArrayLiteral. Let be BitArray. True, false, true. Just realized we probably want to actually test these, but let me copy this into the playground just to make sure they're valid examples instead of lies. Okay. And print C prints false, true, false, quoted so that, well, I guess we don't have to say the word here. Okay, what other things we can say? Oh, yeah. Any other things we need to specialize? We can get into the nuance of field patterns and others, but no, it's not necessary. Maybe we can flip these variable names. So this, let's call this C, this D, and D is created from C, and print D, C equals D. The reason is I want to make workspace for the copy example. Okay, so that is an okay description. We can say see BitArray.swift for more information. May even want to link to it. Maybe we just say source code. Okay, installation. Again, back to cheating. Downloads, README. This stuff is all the same, so we can get it here. Literally swap some words. The project name is different. The rest should be the same. I don't like some of this wording, but we can change that. Okay, I like to point out the fact that you can also integrate with Xcode. So include this is Ruby, right? Getting distracted all over the place. Include BitArray.Xcode proj in a workspace the old-fashioned way. Okay, we've done our license, so it's MIT license. And let's link to it as well. The link to the license is this. Okay, so this is README done. Okay, contributing, which is tricky. We probably want like code of conduct separately here. But for contributing though, I'll just put in something generic, right? Fork the project, well, make a pull request. Make sure you include ink-tree make sure to update change log for your change. Wait for CI to clear to go green. Work on feedbacks from reviewers. Someone will merge a committer will merge your changes when it's ready. Okay, how to contribute. Okay, that's a laughable contributing .md, but you know, it's as a first release, it's pretty good. I just really realized the thing that's missing here would be a changelog. But again, we can cheat, right? So changelog, copy it. And since we're starting from 0.0.1, we don't have to put anything changelog because we're, it's not 1.0, and by definition, by SemVar, that's not stable. We'll start filling in when we are after 1.0. Okay, so what else is there? Yeah, we're almost done. Let's make some commits. Oh no, I forgot to add tests. You know what? I'll add it off camera. So what's in this change? This is the source code change. So we'll have new stuff, new functionality, and documentation. Okay. New interfaces and docstring. Oh, don't want to include the to-do file. Okay, and I can now push this content. Should we make a pull request? Yeah, why not? Okay, pull request made. Hopefully that'll go green. And then the last thing I needed to do is make a tag. So this makes it official, right? I think is not ready yet, so I'll skip that as well. But all I was going to do is get tag 0.0.1 and then push up the tag. Yeah, great. So yeah, that's more or less what I needed to do. So final update, the pull request was cleared by CI. I added some more tests so that I'll feel better about it. And yeah, and let's merge it. And there we go. Thanks for watching. If you enjoyed this video, please consider subscribe to my channel. And I'll see you in the next one.